Hey there, I'm Mosh and welcome to Python Projects for Beginners. In this course, we're not just going to build some cool Python projects, we're going to dive deep into the process of thinking like a programmer. Coding isn't just about getting things to work, it's about understanding the problem, breaking it down, and building solutions that are clean, maintainable, and actually make sense. Most courses will show you how to write code, but they don't teach you why you're writing it that way. Here, I will walk you through my entire problem-solving process from the initial idea to the final polished solution. By the end of this course, you won't have just cool projects under your belt, you'll have the skills to tackle coding challenges with confidence and write code that you can be proud of. So if you're ready to go beyond just coding and start thinking like a problem solver, let's dive into Python projects for beginners. Now, before we jump into projects, I want to quickly talk about what you'll need to know to get the most out of this course. You don't need to be a Python expert to follow along, just a basic familiarity with Python is all that's required. If you know how to work with variables, loops, functions, and maybe a little bit of file handling, you're all set. As we go through the projects, I'll be using some more advanced Python features here and there, but don't worry, I'll explain those concepts thoroughly as we encounter them. If you feel like you need a little refresher or you want to dive deeper into Python, I've got you covered. You can check out my Python tutorial on YouTube where I'll walk you through the basics in a clear and easy to understand way. And if you're looking to really master Python, I've got a full course on my website that takes you from the basics to advanced concepts. The links are below this video. Now, I want to quickly go over some of the materials that come with this course. First, we have the project handbook. This is a PDF that outlines all the projects we're going to work on together. For each project, I've included additional challenges for those of you who want to push yourselves further. Next, all the code we write in this course is available on GitHub. This is where you can find the complete source code for each project. Whether you want to compare your solution with mine or just grab the code to experiment with, it's all there for you. You'll find the links to both the project handbook and the GitHub repository right below this video. All right, with that out of the way, let's move on to the next lesson. Before we dive into the projects, I want to take a moment to talk about how I've structured this course and how you can get the most out of it. I've designed this course to be hands-on and practical. For each project, I'll start by showing you the project and its requirements. At this point, I encourage you to pause and try to work on the solution on your own. This is where the real learning happens, by thinking through the problem and applying what you have learned so far. Once you have given it a shot, come back and watch how I break down the problem into manageable steps and start coding the solution. Your code may be different, and that's totally fine. I don't expect your solution to be exactly like mine. We all think differently. Use my solution and code as inspiration to see if there are better ways to write code. For the first few projects, if you feel like you are not quite ready to start and finish a project on your own, just watch my solution and code along with me. Then, once you have a bit more confidence, tackle the other projects on your own and then come back to see my solution for ideas to improve your code. Look, I've been coding for over 25 years and I still encounter challenges depending on the projects I'm working on. So if you find some of these projects difficult, don't be discouraged. That's part of your learning journey. The things that feel complex today will eventually become simple and you'll be ready to take on new challenges. Remember, this course isn't about quick wins. It's about building a strong foundation in problem solving that will serve you throughout your career. By the end of each project, you will not only have a working solution, but also a deep understanding of the logic and thought process behind it. Now let's get started. All right, for our first project, we're going to build a dice rolling game. So let me show you what happens when we execute this program. First, we get this question, roll the dice. Here we have only two options, yes or no. If we type anything else, we get an error message saying invalid choice. Now we can type a Y, either lowercase or uppercase, it doesn't matter. And every time we get two new random numbers, just like how we roll a dice. Now, if we type N, our program terminates and displays a message saying, thanks for playing. Now, I want you to spend 10 to 20 minutes on this project and then come back and see my solution. All right, before we jump into coding, I always take a moment to map out what I want to do, kind of like checking a map before we start a road trip. It helps me see the big picture and avoid getting lost along the way. So let's quickly plan our approach before we start writing any code. Trust me, it makes things much smoother. So in this Python file, I'm going to use comments to map out how this program should behave. So first, we should ask the user a question, like roll the dice. Then we should check the user input. So if user enters y, then we should generate 2 random numbers and print them. Otherwise, if the user enters no, then we should print a thank you message and terminate the program. Otherwise, if the user types anything else, we want to print an error message like invalid choice. Now, we want to make sure that the user can keep playing until they decide to terminate the game. So we should put these instructions inside a loop for repetition. So everything here should go inside a loop, an infinite loop, okay? Now let's start converting these comments into actual code. So first, we're going to ask the user to roll the dice. And to do that, we use the input function. Now here we should type a prompt. We can use double quotes or single quotes. Different people have different preferences. Whatever you like, just make sure to stick to that. So here I'm going to ask roll the dice and give the options yes or no. We add a colon followed by a white space. So whatever the user types will be separated from our prompt, okay? Now we'll store the result in a variable. We can call it choice. Next, we should check if choice equals y. So if choice equals a lowercase y or choice equals an uppercase y, that's one way to do this, but there is a smarter way. We can treat whatever the user types as lowercase. So look, if you hover our mouse over this choice variable, look at the type. The type is a string. So the input function returns a string, and you know that in Python, string objects have a bunch of methods. So here we can use the lower method to convert whatever the user types into lowercase. With that, we can get rid of the second condition. Okay? Now we should generate 2 random numbers. And to do that, first we have to import the random module. Now, in this module, we have a method we can call random.randint to generate a random integer or a random number between these 2 numbers, a and b. In this case, 1 and 6. Now, this returns a random number, so we store it in a variable like die1. Now, we have to repeat this to generate the second random number. Next, we should print these numbers. So here we call print. Now, for simplicity, we can use a formatted or an F string. So we type an F before our quotes, and here we add parentheses. Inside the parentheses, we want to print our random numbers like 1 and 2. But instead of hard coding these numbers, we want to print the actual random numbers that are generated here. So we replace 1 with curly braces to add a placeholder or a hole in our string. And inside this hole, we add die1. And similarly, replace 2 with curly braces and add die2. So we print these numbers. Next, we should check if the user types an n. So elif choice equals n. Then we want to print a thank you message. So thanks for playing. Now, to terminate the program, we want to break out of our loop. Now, we haven't added the loop here, so on the top. Now, there are 2 ways to do this. Some people like to declare a variable like running or playing and initialize it to true. Then they add it as the loop condition. So while playing is true, then we're going to repeat these instructions. And when the user types an n, we can use the break statement to jump out of this loop. That's one way, but there is a better way. This variable here is really unnecessary. So we can use true as the condition for this loop and get rid of 1 extra line of code. Also note that it's a good practice to add a line break between our import statements and the rest of the code. It makes our code cleaner and easier to dice. So we're almost there. Now finally, if the user types anything else, we want to print an error message. So print invalid choice. As simple as that. That was our first project. Depending on your programming skills, this might be too easy for you, but don't worry. As we go through this course, our projects will gradually get more complex. Now, if you want to challenge yourself, look at the workbook that I gave you at the beginning of the course. After each project, there are ideas for enhancing the program and challenging yourself. All right, for our next project, we're going to build a number guessing game. So here's how it's going to work. When we run our program, it generates a random number between 1 and 100 that we have to guess. Now, if we type an invalid number like A, we get an error message. So let's type a valid number like 50. Now, the program is giving us feedback. It says this is too high. So let's try 25. It's still too high. What if we try 10? Still too high. How about 5? Now it's too low. So the number that the computer has generated is between 5 and 10. Let's try 7. It's too low. Let's try 8. There you go. We guessed the number. So spend 15 to 20 minutes on this project and then come back and see my solution. All right, once again, before we write any code, let's map out what exactly we're going to do. So first, we should have our program generate a random number. Then we should ask the user to make a guess. Now, we want to make sure that the user enters a valid number. So if the user enters an invalid number, so if not a valid number, then we want to print an error. Otherwise, we should give the user some feedback. So we can say if this number that the user entered is less than the number to guess, we can say this is too low. Otherwise, if this number that the user entered is higher than the number to guess, we can say this is too high. Otherwise, that means number equals guess, right? So in this situation, we should say, hey, well done, you made a guess. Now, we want to make sure that the user can make multiple guesses. So except the first line, we should put the rest of our code inside a while loop for repetition. So here's the structure of our program. We don't want to add the first line inside a loop because we want to generate a random number only once, okay? Now, let's convert these comments into actual code. To generate a random number, first we import the random module. Then we add a line break to separate our import statement from the rest of our program. Next, we call random.randint to generate a number between 1 and 100. Let's store this in a variable called number to guess. Always use descriptive names for your variables. So don't use variable names like n or x or a because someone else reading your code, they have no clue what these variables represent, okay? So number to guess. Next, we should ask the user to make a guess. So I don't want to add the loop yet. Let's just convert this comment into code. So here we call the input function and tell the user to guess the number between 1 and 100. Now, you know that the input function returns a string, so we can store it in a variable like user input. Now we should convert this to a number. And to do that, we use the int function. We pass user input and store the result in a variable called guess. Now, look, user input is only used in a single place. There is no need for this variable anywhere else in this program because for the rest of our program, we're going to work with this integer. So we can simplify our code and make it more concise by removing this variable. It's unnecessary. So we can get the string that is returned from the input function and pass it directly to the int function. With this, we can remove this unnecessary variable. So when this program is executing, first, the input function is called, then the return value, which is a string, is passed to the int function, okay? Now, how can we validate that this is a valid number? Well, before we do that, let's just print guess on the terminal to see if our program works up to this point. So this is a good technique for building larger programs. Always do it in baby steps. So instead of implementing the entire program, do it in baby steps, make sure it works, and then move on. So here in the terminal, let's run our program. and enter an invalid number like A. All right, look, our program crashed because an exception is thrown on this line. And here's the type of the exception, value error. So to handle this situation and prevent our program from crashing, we have to add this line inside a try block. So we type try, then add indentation. Now right after try, we should type except, followed by the type of error we want to handle. In this case, value error. Okay? Now, if we end up here, we want to print an error message and say, please enter a valid number. Okay? Let's run our program one more time. So I type A. Okay, this time our program didn't crash. Instead, we got a friendly error message. Beautiful. So we're done with this step. Now, we should give the user some feedback. So after the except block, I want to add a line break to separate this bit of logic from the rest of the logic, which is about giving the user some feedback. So using these line breaks is like how we break up a story into multiple paragraphs. Imagine if you read a book and there are no paragraphs. Obviously, reading that book is very difficult. So here we can check if guess is less than number to guess. We print a message and say too low. Now here we have an error message on the guess variable saying guess is possibly unbound. I know this is a weird error message, but basically this is happening because we have declared this variable inside the try block. So it's only meaningful inside the try block. This is called the scope of this variable. So to fix this error, we have to move these two lines inside our try block and add indentation. So we read a number, then we check if it's less than the number to guess. Otherwise, elif guess is greater than number to guess, we print too high. Otherwise, that means the user guessed it correctly. So here we can say, congratulations, you guessed the number. Now let's get rid of these comments. We don't need them anymore. Now we want to put all these instructions inside an infinite loop. So here we type while true and move all these lines inside our loop. Now, after congratulating the user, we should use a break statement to break out of this loop. Okay? Now let's run our program and see what happens. So first we enter an invalid number. Okay, we got an error message, so we can try again. Let's type B this time. Beautiful. Now let's type a number like 50. It's too high. Let's try 25. It's too low. So let's try 40. Too low. What about 45? Too high. So it's between 40 and 45. Let's try 43. It's too low. It has to be 44. Okay, our program terminated. All right, our next project is a fun game that we have all played in our childhood, rock, paper, scissors game. Now, this project is a little bit more challenging than the previous projects, so let me run the program and show you how it works. First, we get a question, rock, paper, or scissors. Here we only have three choices, R, P, or S. If we type anything else, we get an error message saying invalid choice. Now, let me go with R, that is short for rock. So I chose rock, computer chose paper, and I lost. Now, right after, we get asked if you want to continue. Let's try again. This time, I'm going to go with scissors. So I chose scissors, computer chose paper, I won. Now, I don't want to continue, so let's type N. The game ends. Again, this project is a bit more challenging than the previous ones, so spend about 20 to 30 minutes on this, and then come back and see my solution. All right, once again, before we write any code, let's map out what we're going to do. So first, we're going to ask the user to make a choice. Now, if the choice is not valid, we're going to print an error. Otherwise, we should let the computer to make a choice as well. Next, we should print the choices using emojis. And this is the fun part. Next, we should determine the winner. And finally, we ask the user if they want to continue. If not, we're going to terminate the game. So this is the structure of our program. Now let's start coding. So first we should ask the user to make a choice. To do that, we use the input function. Here we type rock, paper, or scissors. And in parentheses, we can type the valid options, so R, P, and S. Now we get the result and store it in a variable called user choice. Next, we should validate the choice. So just like before, here we're going to call the lower method so we can treat the user's input as lowercase text. We talked about this technique in one of our earlier projects. Now to validate the user's choice, here we can use a bunch of if statements. So we can say if user choice does not equal R and user choice does not equal P and user choice does not equal S, then we can print an error message and say invalid choice. That's one way, but this is not a very clever or very professional way to implement this. There is a better way. We can store the list of valid choices in a list and then check to see if the user's choice is in that list or not. So in the first line, we can declare a variable called choices and initialize it to a list of valid choices. So R, P, and S. Now we can simplify this if statement and say, if user choice not in choices, then print an error message. This implementation is more concise and more elegant. Now we can further improve this and convert this list to a tuple. Why? Because lists can be modified in our program. So somewhere we might accidentally modify the list and use the append method to add a new item to the list or remove method to remove one of the existing items. This could be an accidental mistake. But if we convert this to a tuple, it becomes read-only. So tuples, look, they don't have the remove or append methods. So a tuple is just like a read-only list, okay? So we have our valid choices and we are done with this step. Now, before going further, let's test our program. So I'm going to remove these two lines. Now back to the terminal, let's run our program. So if you type A, we get an error message, beautiful. But if we type R, we don't get an error. Great. Next, we should let the computer to make a choice. And to do that, first we have to import the random module. Now, earlier we used the randint method to generate a random number between two numbers. But here we want to use a different method, and that is choice. With this, we can pass a list or a tuple like choices and let the computer choose one of these valid choices. So let's store the result in a separate variable like computer choice. So we're done with this step. Now let's print the choices. So first I want to print the choices without emojis just to make sure that our program is working up to this point. So here we can type you chose and then use concatenation to append user's choice here. That's one way, but a better and more elegant way is to use a formatted string. So we prefix the string with an F, which is short for formatted. And here we add curly braces to insert a value dynamically, in this case, user choice. With this, we don't have to use concatenation. Okay? Similarly, we can duplicate this line and say computer chose. And here we add computer choice. Okay? Let's run our program. So I type R. Okay, we both chose rock. Let's try again. That's weird, it's happening twice. Let's run it one more time. I'm going to select S. Okay, so I selected scissors, computer selected rock. Beautiful. Now we should print emojis. How can we do that? Well, there are two ways. One way is to use an if statement and say, if user choice equals R, then we can print an emoji. On Mac, you can bring up the emoji keyboard by pressing Control, Command, and Space. On Windows, I'm not entirely sure. So here we can type rock and select this rock. Okay. Now, similarly, we can add a second condition and say if user choice equals S, then we're going to print scissors. But again, this approach is not the best way because we need 3 if statements to map these letters to emojis. Let me show you a better way. First, let me remove these few lines. Okay. Now, in Python, we have a data structure called a dictionary. A dictionary is used to map a key to a value. So we can map the character R to the emoji of a rock. Similarly, we can map the letter S to scissors. Okay, now how can we declare a dictionary? Well, here we can declare a variable called emojis and set it to curly braces. Inside the braces, we type key value pairs. So our key is going to be R, then we type a colon and map it to the emoji of a rock. Note that in this case, both our key and value are strings, but this is not a requirement. So we can map a string to a number or an object, whatever we want to do. Now, similarly, let's map S to scissors and also P to paper. Okay, now let's remove these comments. Back to the part about printing the user's choice. Instead of printing the user's choice, which is a letter like R, P, or S, we are going to go to this dictionary and look up the value associated with a given key. So here we type emojis. Then using square brackets, we can look up the value associated with one of these keys. Now here in the auto-completion box, we can see the valid keys, which are P, R, or S, but we're going to replace this with user choice. Now similarly, here we type emojis and pass computer choice. Let's run the program one more time. If I type R, I get rock and computer chose scissor. Beautiful. All right, we're done with this step. The next step is determining the winner. Now, before moving forward, I want to add some line breaks to divide our code into different segments, just like the paragraphs of an article. So on the top, we are declaring our emojis and valid choices. These two lines are highly related, so I want to keep them together. But look at the next line. The next line is about getting the user's input. This line has nothing to do with the previous lines, so it's like a different paragraph in a story. So here we add a line break. Now again, these three lines are highly related because they are part of getting the user's input. So we want to keep them together, but separate them from getting the computer's choice. Now, once again, we add a line break here because this segment is all about printing the user's and computer's choice. Okay? Now, let's move on to the next segment, which is determining the winner. So we add a line break, and here we can check if user choice is the same as computer choice, then we print tie, else if, or elif. Now, here we want to implement the scenario where the user wins. There are three scenarios. One is user choice is rock and computer choice is scissors. In this case, we want to print you win. There's another scenario where user's choice is scissors and computer choice is paper. Again, here we can print you win, but there is a better way. We can combine these two statements into a single statement using the logical OR operator. So this is one scenario or one condition where the user wins. As you can see, I've selected this expression. Now we type left bracket, so the entire expression is now surrounded by parentheses. Right after, we type OR. Now here, we should select our second condition. Again, we type a left bracket to surround this with parentheses. Now we select the entire expression, cut it, and put it right here. Now, similarly, we type another OR operator and add the third condition, and that is user choice equals P or paper and computer choice equals rock. So if any of these conditions is true, the user wins. Otherwise, the user loses. Okay? Now, this line is getting a little bit too long. So to make our code more readable, we can break it down into multiple lines. So right after this OR operator, we add a line break. Now, here we have an error saying expected expression because Python interpreter expects a colon here. So to tell the interpreter that this is a multi-line statement, here we add a backslash. Okay? Now, to better format our code, it's better to line up all these conditions. So we put this on a new line, add tab. Again, on this line, we add a backslash. Now, these two conditions are perfectly aligned. Now, similarly, let's add another backslash and put this condition on a new line. Now, what is happening here? We had an extra white space. Okay, we are good. So this is one way to break this code down into multiple lines, but all these backslashes are kind of ugly. Let me show you a better way. Look, here we have 3 conditions, each surrounded by parentheses. Now we can grab all these 3 conditions and wrap them with parentheses like this. We can remove the backslash. Here we add parentheses. So the left one is here and the right one should be at the end, right here. With this, we no longer need these backslashes anymore. So Python interpreter knows that this outer parenthesis represents a long expression. Okay? So we're almost there. We determined the winner. Next, we should ask the user if they want to continue. So once again, we add a line break to separate this segment from the previous segment, which is about determining the winner. And then use the input function to ask the user if they want to continue or not. So right away, we call the lower method and then store the result in a variable like should continue. We cannot use the word continue because this is a reserved keyword in Python, okay? So here we check if should continue equals n. Then we want to terminate the program. Now, to do this, first we have to add these statements inside a while loop. So here we add a while loop with true as the condition. Now, let's indent all these lines. So if the user types an n, then we want to break out of this loop to terminate the program. Otherwise, if they type y or anything else, we can treat it as yes. So let's run our program. First, let's try an invalid choice, like A. All right, our program crashed on this line, line 13, where we try to show the emoji associated with the user's choice. Now, obviously, in this dictionary of emojis, up here, we don't have a key with the value of A, right? So look, down here, we are validating the user's choice. If the user types an invalid choice, we just print an error message, but the rest of the code gets executed. So we end up on this line, and this line throws an exception. To fix this issue, right after printing an error, we should use the continue statement to jump back to the beginning of the while loop. So we ask the user one more time to make a choice. Let's try it one more time. If I type an A, we get an error message and our program doesn't crash. Beautiful. Let's try again. B, great. Now if I type R, I chose rock, computer chose scissors, and I won. Beautiful. Now, shall we continue? If I type yes, I get a chance to make another choice. Let's go with P. I chose paper, computer chose rock, so I won again. Great. Now if I type N, our program terminates. All right, our program is working, but just because it's working, it doesn't mean our work is finished. We should always review our code and find opportunities to refine and improve it. In coding, this is called refactoring. It's basically a fancy term for changing the structure of our code without changing its functionality. In this lesson, we're going to look at a common refactoring technique called modularization. Modularizing code means breaking down a large program into smaller, reusable parts called modules or functions. Think of it like organizing a messy room into different boxes, each holding specific items. Instead of having one big pile of everything, we put related things together, making it easier to find what we need and keep things tidy. Now, back to this code. Earlier, we talked about different segments in our program. So we have a segment for displaying choices. We have another segment for determining winner and so on. Now we're going to extract these segments into small functions, each having a single responsibility. Let me show you how we do this. So we start from the top. These few lines have a single responsibility, and that is getting the user's choice. So we can extract these few lines into a separate function called getUserChoice. So up here, after we declare our emojis and choices, let's define a function called getUserChoice. choice. Always use descriptive names for your functions, okay? Now let's move these few lines inside this function. Now here we have an error because the continue keyword can only be used inside a loop. So here we need to add a while loop, while true. Then we move these few lines inside this loop. So if the user enters an invalid choice, we print an error and then continue, which means we jump to the beginning of the while loop. Otherwise, we break out of this loop, and at the end, we should return a value from this function. What value? User's choice. So here we use the return statement to return user choice. Now there is a better way to write this code. Instead of breaking out of this loop, we can return user's choice right here. So return user choice. With this, we can make our function slightly shorter, okay? Now, let me show you what happens if we swap these if and else statements. So instead of checking if user choice is not in the list of choices, we check if user choice is in the list of choices. In this case, we're going to return immediately. So return user choice. Otherwise, we're going to print an error message and continue. Okay. Now with this implementation, we don't even need the continue keyword because if we end up here, we print an error and then the control automatically moves to the beginning of the while loop. So we can get rid of the continue statement and make our code slightly shorter. Okay. Now back to our main while loop. Earlier, we had a few lines for getting users input. Those lines are now inside the get user choice function. So here we call get user choice, get the result and store it in a variable called user choice. Okay. Next, we're going to apply the same technique to these two lines. These two lines are highly related and have a single responsibility, displaying choices. So let's select these two lines, cut. Now, after this function, we define another function called display choices. Good. Now, back to our while loop. Right here, we call display choices. Okay. Next, we need to extract these few lines for determining the winner. Again, select, cut. Let's define a new function, determine winner. Now here we have an error because we need to add indentation here. Good. Now back to our while loop. After we display the choices, we call determine winner. Good. Now we can do the same thing with our while loop. So we can extract this entire logic and put it into a separate function. Let's call that play game. This is where we have our game logic. Let's select all this code and add indentation. Good. So here's the end result. Now, if you look up here, we have a bunch of errors because in this function, display choices, we do not have a variable called user choice. This variable is declared inside our play game function. So to fix this issue, we have to pass user choice and computer choice to these functions. So we go to our display choices function and give it two parameters, user choice and computer choice. Now the errors are gone. Similarly, in determine winner, we add two parameters, user choice and computer choice. The errors are gone. Beautiful. Now, when calling these functions, we should pass these values as arguments, user choice and computer choice. One more time, user choice and computer choice. Good. Now, one last thing. If we run our program, nothing happens because after this refactoring, we move different lines of our code inside different functions. But currently, none of these functions is getting called. So at the end, we have to call the play game function. So our program starts. Let's run it one more time. There you go. Let's enter an invalid choice. It's still working. Let's type R. Our program is working. And let's terminate it. Beautiful. So with this refactoring, we broke down our program into smaller, reusable functions. Each of these functions has only a few lines. So if there is a bug in one of these functions, we can only focus on those few lines. This is easier than reading and understanding an entire script. This is the benefit of modularizing code. We have one more opportunity for improving this code. Look, there are multiple places where we have defined our choices. This is bad for two reasons. One reason is that if we have a typo in our code, our program is not going to work. That's number one problem. The second problem is that if tomorrow we decide to change our choices from R, S, and P to something else like 1, 2, and 3, there are multiple places that we have to modify. In programming, we have this principle called DRY, which is short for don't repeat yourself. So we don't want to have repetition or duplication in our code. Most of the time, it's a bad practice. So how can we solve this problem? Well, we can generate this tuple based on this dictionary. In this dictionary, we have 3 key value pairs. Our keys are R, S, and P. So let me show you how we can convert this dictionary to a tuple with these values. First, I'm going to select this line and the rest of the code. Now, we can convert all these lines to a comment by pressing Command and slash on Mac or Control and slash on Windows. Now, all these lines are commented out, so they're not going to get executed. We only have the declaration of our dictionary. Now, let's print emojis dot. Look, here we have a method called keys, which returns the keys of this dictionary using this structure, dict keys. Let me show you. So back to the terminal, let's run our program. All right, here's what we get. We get an object of type dict keys or dictionary keys. And here we have R, S, and P. But this is not exactly what we want. What we want is a tuple. But this is very easy to fix. We can pass the object that is returned from this method to the tuple function. And with this, we get a tuple exactly like the tuple that we declared here. So we can set choices to tuple of emojis.keys. Okay? With this technique, we removed duplication in our code. Now, let's bring back all the code here. So one more time, we press Command and slash on Mac or Control and slash on Windows. Okay? Now, look, there are other places where we have repeated our choices. Again, if we have a typo, our program is not going to work. So realistically, we need a single place for defining our choices. To do that, we can go to the top and declare a bunch of constants. By convention, we use uppercase letters to declare constants. So we can declare a constant like rock and set it to R. Similarly, scissors and paper. This is a single place where we declare our choices. Now, anywhere we have R, S, and P, we replace them with our constants. So I have selected R here. Now, to select the next occurrence of R in this code, we press Command and D on Mac or Control and D on Windows. Look, this instance is also selected. One more time, we press Command and D. There you go. Now we have 3 cursors, all of them selecting R. So we can replace them all with rock in one go. Now to cancel multi-cursor editing, we press the escape button twice. Okay? One more time, we're going to select S. We press Command and D twice to select these 2 instances as well and replace this with scissors. Again, we press the escape button twice. Done. And the last one, paper. Okay? Now, we have a single place where we have defined our choices, so no chance for typos. And if we decide to change the choices from R, S, and P to something else in the future, there is a single place we have to update. We can change this to 1, 2, and 3, and everything will work. Okay? But there is another benefit here. Look, down here where we determine the winner, our code is more descriptive. So instead of comparing user choice and computer choice with R and S, we can clearly see that if the user has a rock and the computer has scissors, the user is the winner. Hey there, I hope you've been enjoying this video so far. If you're finding this helpful and want to take your Python skills even further, I've got something really exciting for you. This video is just a taste of what you will find in my full course, Python Projects for Beginners. In the full course, we dive deep into more projects covering a wide range of concepts that will help you sharpen your problem-solving skills and become a confident Python programmer. If you're ready to level up, check out the link below to get access to the full course. I would love to see you there and help you on your Python journey. All right, for our next project, we're going to build a QR code generator. So first we enter some text or URL. I'm going to enter the address of my website, codewithmosh.com. Next, we enter a file name. Let's enter mosh.jpg. Now we have a QR code saved in this file. This file is right here. So this is the QR code for my website. If you scan this with your phone, it will open your browser and take you to my website. Now, to build this, we're going to use a third-party library called QR code. So head over to pypy.org/project/QR code. Read the documentation for this library. The purpose of this project is to get you familiar with using third-party libraries. So this project doesn't have really complex logic. It's all about the right way to use third-party packages. So I spent a few minutes to go through the documentation, then install this library and build this project. All right, the first thing we're going to do is set up a virtual environment. A virtual environment in Python is like a separate, isolated workspace on your computer where you can install packages and run Python projects. Think of it as a clean, organized room that's separate from the rest of your house. In this room, you have everything you need to work on a specific project without affecting anything else in the house. Now, why do we need a virtual environment? Well, imagine you're working on two different Python projects. One project needs an older version of a library, and the other project needs a newer version. If you install both versions globally for the whole computer, they might conflict with each other. A virtual environment solves this problem by allowing each project to have its own separate environment with its own specific versions of libraries. Okay? So to set up a virtual environment, here we open the terminal window and type Python if you're on Windows or Python 3 if you're on Mac. Then we type -m, that is short for module. We're going to run this module venv. That's one of the built-in modules in Python for creating virtual environments. And then we specify a name for our virtual environment. By convention, we often use venv as well. Okay. Now, VS Code is saying we noticed a new virtual environment has been created. Do you want to select it for the workspace folder? For now, select no. We'll come back to this later. Now, take a look at the project directory. We have this new folder here, venv, and inside this, we have a bunch of folders like bin, include, and lib. Inside the bin folder, we have executables like pip, pip3, Python, Python 3, and so on. Now, if you're a bit more experienced and are familiar with Git, you can see that we have over 1,000 files ready to be committed to our repository. We don't want to include these files in our repository. So to exclude them, here in the root of our project, we add a new file called .gitignore. In this file, we add the files and folders we want to exclude from our Git repository. In this case, venv folder. So we add a / here. Okay. Now, if you're not familiar with Git, don't worry about it. Just ignore this step for now. Okay. So we have created a virtual environment, but currently it's not active. So we go back to the terminal. To activate it, if you're on Windows, you type venv /scripts /activate. If you're on Mac, you type source venv /bin /activate. Okay. Now look, this virtual environment is activated. So any packages that we install will be installed in this virtual environment or in this isolated workspace. When we are done with this project, we can deactivate this virtual environment by typing deactivate. Okay. Now let's activate it one more time. Good. Now in this virtual environment, we're going to install the QR code package. All right, good. With this installed, now we add a new file to our project, qrcodegenerator.py. First, we import the QR code module. Next, we use the input function. And tell the user to enter some text or URL. We get the result and store it in a variable called data. Next, we use the input function to get a file name. So enter the file name and we store it here. Now, it's a good practice to remove any white spaces around what the user types. For example, what if the user types, let's say, the address of my website as the URL? Whether they type this address or this address followed by a white space, we want to have the same QR code generator. So over here, we can call the strip method to get rid of any white spaces around our data, okay? Similarly, I would like to strip any white spaces around the file name. Good. Now we are ready to generate our QR code. To do that, we go in the QR code module and create a QR code object. Here we want to set two parameters. One is box size. I'm going to set it to 10. These are just arbitrary values. I'm going to set border to 4. This returns a QR code object. We store it in this variable. Next, we call qr.addData. Then we pass our data. Next, we call qr.makeImage and set two arguments here. One is fill color, which I'm going to set to black. Again, these are arbitrary values. You can use any colors you want. We also set back color to white. This returns an image that we store in a variable. And finally, we call image.save to save it in this file. And at the end, we print QR code saved as. Now here we want to add the file name. So let's convert this to a formatted string and insert the file name here. Now let's run our program. So I'm going to enter the address of my website, codewithmosh.com. And for the file name, I'm going to enter mosh.jpg. Okay, now look in this folder, we have mosh.jpg. This is my QR code. So if you point your phone at this and scan it, this will open your browser and take you to my website. Hey there, I hope you've been enjoying this video so far. If you're finding this helpful and want to take your Python skills even further, I've got something really exciting for you. This video is just a taste of what you will find in my full course, Python Projects for Beginners. In the full course, we dive deep into more projects covering a wide range of concepts that will help you sharpen your problem-solving skills and become a confident Python programmer. If you're ready to level up, check out the link below to get access to the full course. I would love to see you there and help you on your Python journey.